welcome to section 6.6, dilations, the last transformation that we have of the unit. Before we go into what a dilation is, I want to practice right here. I want y'all to look at this, and I want you to look. We have multiple transformations going on here. The first thing that we're doing is we are reflecting across the line y equals x. So you know that rule. And then we are rotating 180 degrees about the origin. So given these four ordered pairs, after those two transformations, what would happen? And there's a reason why they have R double prime, A double prime, P double prime, and C double prime is because there were two transformations to get there. So pause me and try to figure out which one that would be. All right, so what I did was I first, you can see my work. If you look at this, I talked about, okay, I know I'm going over the line y equals x, where I just switch x and y. And then I'm going over 180 degrees where you just change the sides. So the answer is D on that one. That's just a little refresher. All right, note card 215. What is a dilation? A dilation is a proportional stretch or shrink of an image on the coordinate plane based on a scale factor. There are other words you can use instead of stretch or shrink, a compression, things like that. But overall, just know that it's a stretch or a shrink. We're going to be looking at them like this, and our center of our dilation is going to be the origin. And so if you look, ABC right here is made bigger. So it's dilated, it's a stretch to A prime, B prime, C prime. Then of course, I really just like the little penguin. This is a reduction, this is an enlargement. So again, you can call them reduction or enlargement. So pause me and finish up note card 215. All right, note card 216, I really want to look at some of the descriptions and properties of a dilation. The description of the dilation includes the scale factor in the center of the dilation. In Math 2, the center of the dilations will be the origin. They'll be 0, 0. Okay, so if you see this notation, a big D meaning dilation, the thing in front of the comma is the center of the dilation, which is going to be 0 in Math 2. And over here is your scale factor. So in this particular one, the center is 0 and the scale factor is 1/3. So that's going to be a reduction or a shrink. If the scale factor K is greater than 1, the dilation is called an expansion, a stretch, an enlargement. If the scale factor K is between 0 and 1, the dilation is called a contraction or a shrink or, oh gosh, the word just left me, a reduction. Okay, so all of that needs to be written down. It's a lot. And some of the properties that are preserved, meaning that stay the same, is angle measures stay the same. It's the same shape, y'all. The size is going to be the same. The shape is going to be the same shape. It won't be the same size, but it'll be the same shape. Parallel lines stay parallel. Collinear points that are on the same line are going to be on the same line. Midpoints, the same. Orientation's the same. Dilations create similar figures. So I think you might be seeing where we're going to go with this in our next lesson. We have similar things, similar triangles, similar things. So your sides are in proportion. So pause me and finish up note card 216. All right, note card 217. Let's jump into an example of a dilation. So we want to find the image of a triangle ABC. So here's your original points A, B, and C. And what we're doing is a dilation around the origin, and it's of 2. So it's going to be an enlargement. So all you have to do is multiply each ordered pair, each thing, by 2. So that's what we did. A prime, B prime, and C prime. And then if you graph the original, and so the pre-image and the image, you'll see that it's double the size. It's the same orientation, it's the same shape, but its size is doubled. So pause me and finish up note card 217. All right, note card 218, another example. We still have a centered origin dilation, and I know that might be hard to see, but right there, the scale factor is -1/2. So we will multiply each of these ordered pairs by -1/2 and get this, and you'll see that it is moved a little bit. It's moved around because of that negative. So that's funky. This one does not actually preserve the orientation. The orientation is rotated. But I did want to show you a kind of weird one, a wonky one. So I changed the title of it to Weird and Wonky. Fun, fun. Finish up note card 218.